Welcome to part 2 of our tutorial videos. This video will introduce and explain the input models required to run the MASCEM Spine Toolbox project in the scope of TradeRace. To run the scenario, the user must consider three types of input data, i.e. the input data for the MIBEL day-ahead market, the input data for the validation of the power flow of the electric grid, and the mapping between MIBEL players and their buses in the power network. The MIBEL input corresponds to the request body that will be sent to the electricity market service to simulate a MIBEL day-ahead market session. Looking at its content, it is a JSON file containing all the information necessary to run a MIBEL day-ahead or intraday session. It starts by identifying the name of the market, its type per period, and the list with the player's bids per period. Each bid specifies the period number, the type of transaction, i.e. buy versus sell, and a list of offers. Each offer details its energy amount and price per unit. According to MIBEL, the maximum allowed number of offers per bid is 25. However, MASCEM allows its users to test different alternatives by setting a different number of offers per bid, number of periods, or number of sessions per market type. MIBEL also considers the use of complex conditions. Their use depends on the type of market selected. The day-ahead market only allows sellers to use complex conditions, while intraday markets allow their use by both buyers and sellers. More details about MIBEL inputs are publicly available at https://em.gcad.isap.ipp.pt. After the market clearing, the market operator must validate the power flow feasibility with the system operator to ensure the quality and security of power transmission and distribution. To this end, it requires the electricity market session results, the representation of the power grid considered for the simulation, and the mappings of each player with its bus. The market session results are automatically mapped to the power flow service in the Spine Toolbox project. Users will need to provide the power grid representation considering the existing elements, such as loads, buses, lines, generators if available, batteries if available, to name a few. This example demonstrates the definition of the grid's buses, lines, and external grid, and the type of algorithm to use for the power flow validation. The user may also define the output format, i.e. JSON versus Excel file. Further details about the power flow input data are publicly available at https://pf.gcad.isap.ipp.pt. The player's buses input maps the players participating in the MIBEL day-ahead session with the respective buses defined in the power network. These mappings ease the correct application of the players' market outcomes in their buses for power flow validation. Thank you.